Hi, Miss Valencia. I just had a couple questions. I just had a meeting with my doctor, and I'm just a little confused about a certain questions about the seed therapy. I'm just not really understanding. And I was supposed to come talk to you about it. I figured you might help clear little things up. I have some research here that I did on my own, but I'm still just a little confused about it. Do you mind?
Okay, yeah, sure, Mr. Walker. Take a seat right here.
Thanks.
No
I
problem.
appreciate you taking the time out to help me with this problem.
No.
Very confused and upset about it.
Sure. Okay.
So the first question I really have is, from my knowledge of radioactivity and radiology and all this stuff, I know that it's not really good to be around. I know with the tannings and all this stuff and all the stuff these kids do nowadays, I know it's not really good for you. So why does this doctor want to put radioactivity seeds inside my body to help me with cancer that I could have had from radioactivity in the world? I don't understand why he's doing that.
Okay, yeah, that's understandable. A lot of times patients come in here because they're worried about, radiation, because whenever we hear radiation, we automatically think that it's bad. But in your case, radiation is actually going to be good because the radiation that's going to be administered is going to break down the cancer cells in your prostate. So you have nothing to worry about also, because for medicine purposes, it is very beneficial. And in your case, it's going to be administered, the seed therapy is when the radioactive sample is directly administered through a needle into the site of the cancer. So, if the radiation was exposed to the rest of your body, it may be harmful, but because it's going directly to the site of the cancer, it's not going to be going to your other organs. It's going to be performing exactly what it's supposed to do. It's going to be breaking down the cancer cells, and it's, the radiation isn't going to be going to the rest of your body. So it's actually going to be very beneficial for you.
Huh. It's good to know that I can't really affect any other things. It stays in one spot like that. I actually was able to pull up this chart here, that I don't understand any of these words. It has all these different words in it that I've never even heard of before, and I just want to know if I can give you this chart, maybe you can help me explain it a little bit better. I don't understand. It says something about PD 103 and all these symbols and stuff. I don't understand what any of that stuff means.
Okay. So PD 103 stands for polonium 103 isotope. So an isotope is within an element when the number of protons are the same, but the number of neutrons varies. So when the number of neutrons varies, that means that the mass of the entire element is changed. So as I mentioned, PD 103 stands for the polonium 103 isotope. The Ti capsule stands for the titanium capsule, where the polonium 103, the radioactive material, is going to be located within the titanium capsule. And then there's Au/Cu alloy. These actually serve as non-active metals, and they're going to be X-ray markers. So after the seeds, the seeds being the polonium 103 are administered, once it's administered, we're going to perform an X-ray on you. And the non-active metals are going to make it so that we can see exactly where the seeds are located. So we're going to be able to determine exactly how much radioactivity is in your body.
We're going to be very controlled and everything.
Yeah, so we're going to be able to see exactly where the radioactive seeds are located. We're going to be, know exactly what's going on at all times.
Oh, that's how you're able to make sure it doesn't go into any of my other organs, because you guys control it.
Yeah, we're going to be able to see it because of those metals. Yeah.
Alright, that's good. So now, how is this PD 103 radioactive? Like, do you guys administer something making it radioactive? I don't understand how it's radioactive.
Okay, because like I said, polonium 103 is an isotope. When it's found in nature as an isotope, it's no harm to you. But when it's man-made, that means it's radioactive. Now radioactivity, I'll give you like a little bit of overview about atoms, which are, little particles in the cell.
I don't know about any of that stuff.
Okay, so within an atom, there's a nucleus. The nucleus is the center of an atom, and in the nucleus, there's contained protons, which have a positive charge, neutrons, which have a negative charge, and then there's different shells surrounding the center, which is the nucleus. And those have electrons, which are particles that have a negative charge. So, in the nucleus, when the nucleus emits, or basically like shoots out energy or different particles, that's radioactivity. That means radiation is being emitted. So, PD 103, the polonium 103, the isotope, is radioactive because energy and particles are being emitted from this nucleus.
Alright, that's making sense.
And to relate it back to the seed therapy that you're going through, the polonium 103, when the nucleus is shooting out the energy and the particles, those particles are going to be breaking down the cancer cells within your prostate. So through this process, the radiation is going to be beneficial to you because it's going to be breaking down the cancer cells, and therefore it's going to be decreasing the size of the tumor. And then eventually, hopefully, the point of it is to hopefully break down the entire tumor, and the radiation is going to break it completely down so the cancer is going to be no longer there.
So now, if this stuff is inside my body and it's so beneficial to me, I don't understand how the doctor briefly just said, not to be around any of my grandchildren and not to be around any kids and all that stuff. I don't understand if this is so okay and it's helping my cancer and it's helping this. It's inside my body. I don't understand. Like, am I emitting? Like, I don't understand. Is something coming out of me? I don't understand how it could even harm them to the point where I can't hold them on my lap. Like, I don't understand that. That's disappointing. I don't get that.
Okay, well, the reason for that being is because even though that it's being administered only in your prostate, the radiation is still going to be emitted out of the polonium element, the isotope.
For 3 whole months?
Well, as it says here, PD-13 has the half-life of 16.99 days.
Yeah, I wasn't getting any of that. I didn't understand that part. What do you mean half-life?
Okay, well, a half-life is half the time that it takes for the radioactive sample to break down into its next form. So, in your case, the polonium-103 is going to be in your prostate. After about 17 days, which is its half-life, only half the initial dose will be radioactive. And then, twice the time in 34 days, only a quarter of the initial dose is going to be radioactive. So then, that being said, it's going to take 3 months for the entire radioactive sample to decay. So for that 3 months, you're still going to be emitting radiation. So, you have to wait 3 months, and then after that 3 months, around that time, it should be completely decayed and you won't be radioactive anymore. Because you're using it for medical purposes, which means that it's going to be beneficial to you. But like you came in here saying, that radiation really, it's not good for other people. So while the radiation is still going to be emitted from your body, it may, produce harmful effects on your grandchildren or anybody else that's not using it for medical purposes.
That makes a lot more sense. Yeah, I wouldn't want to have to deal with any of that stuff. So now, I noticed on that chart, it says something about electron, some capture or something. I don't know what that is. And how does electron capture have anything to do with the X-rays? It says something about X-rays, and I've had a million X-rays. I know all about X-rays. It's just that electron capture part that I never heard of that before. I don't understand what that is.
Okay, well, like I said earlier, in the atom, there's a nucleus, the center, that has a positive and neutral, positive protons and neutral neutrons. And then on the outside of that is the shells of electrons, which are negative. So I'm sure you're aware, negatives and positives attract. They want to be together. Mm-hmm. So in the nucleus, where the positive protons are located, they're attracting the electrons in the shell outside the nucleus. So that being said, when the electrons in the outside shell, the innermost shell closest to the nucleus, when that electron gets captured by the nucleus because of the protons that are positive, that's electron capture. So when the nucleus captures or takes away that electron in the shell, that's called electron capture. And then when that electron is gone from the shell, the next outer shell is going to be generous. It's going to try, in simple terms, it's going to be generous. It's going to try to give that shell another electron to replace the one that it lost. So when that shell gives away another electron to the next shell, that's going to be emitting photon energy. And then in this diagram, it talks about 20-23 keV.
Yeah, I didn't know KUV. I'd never heard of that.
That's an example of the photon energy that's going to be emitted. And then through this photon energy, X-ray energy is going to be emitted. So that's exactly where the X-ray energy comes from.
Oh yeah, that makes sense. This whole thing has so many big words and so many. I know I know a little bit. I know in general sense. I didn't understand it. This is so confusing, and things on the internet, they make you convinced that you're dying. And I just want to know all the facts and know what all this information is. A little overwhelming. But I think that's really all I had. You cleared up every question I really had, and I guess we're just gonna move forward with this process, and I'm gonna follow up with the doctor, and we're gonna get going on this. Well, I really appreciate you taking the time out to help me and to answer my questions. It was very nice talking to you, and wish me luck, I guess.
Good luck. Good luck, Mr. Walker. Let me know how everything goes.
Well, thank you. I really appreciate it. Have a great day.
Have a great day.